So, Siva sir, in the previous class we discussed about electricity chapter. Now we are going to discuss about same chapter only, problems we'll discuss. We'll see now what we can do. So how many problems we can able to do. So we'll try this. Okay, so we'll see. So welcome to the class. So everyone join to the class. Everyone join to the class. So now we will going to do problems in electricity. Everyone, you can join to the class. Myopia, myopia, myopia. Myopia, myopia, myopia. Myopia, myopia. Myopia, 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 myopia. Near distance we can see myopia, myopia, myopia. For that correction we are using concave lens, concave lens, concave lens, concave lens. Myopia, myopia, myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, hey, myopia, 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 myopia. Myopia, 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 myopia. For the correction we are using, bro, what, bro? For the correction we are using concave lens, concave lens, concave lens, concave lens. Come on, ready? 1, 2, 3. New Cartesian sign convention, new Cartesian Sign convention, all the distance measured from the pole. Distance positive above. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. You Cartesian sign convention. You Cartesian sign convention. Okay, so welcome to the class. Now we are discussing problems, that is electricity problems. Now we will work out on electricity problems. So one by one we will go with that. One by one we will go with that. A copper wire of resistivity. A copper wire of resistivity. So now you can see a copper wire question I am giving. A copper wire. A copper wire. A copper wire of resistivity. A copper wire of resistivity. So resistivity I am giving. Resistivity. So 1 point. So a copper wire of resistivity 1 point. So 1.6 into 10 power minus 8. So 10 power minus 8 ohm meter. Ohm meter has a cross section. As a cross sectional area. As a cross sectional area of, so 20 into 10 power minus 4 centimeter square. Calculate the length. Calculate the length of this wire. Required to make a 10 ohm coil. 10 ohm coil. So you have to understand one thing. 3 points you need to remember. When a question comes, immediately you have to check. And identify. So here I am considering. Immediately you have to check and identify exactly what they given. So here you can observe. In this question. Here we need to underline. We have to underline. Okay, so here a copper wire of resistivity. Here resistivity is given. Resistivity how much? So resistivity is given. This is the resistivity. So you have to write here itself. Resistivity. There is a cross sectional area. Is given. Area of the cross section. So area of the cross section. Calculate the length. So length we have to find out. So length we have to find out. Okay. So we need to identify the length. We need to find out the length. And of this wire required to make 10 ohm. So R we have to find out. So now you can consider. Now I am taking. So now I am considering here. So Cookie, hi. So what's your name? Can I know your name? Good name. So here you can consider whenever they given, you must identify. Okay. So you have to identify the data what exactly they given. Here you can see a copper wire of resistivity. Resistivity is given. A copper wire of resistivity is given and it has a cross sectional area. So area of the cross section is given. Calculate the length of the wire to required make. So now you can observe resistivity is given. So rho equal to given data. So given data. We can consider given data. You have to consider given data. What is the rho value? 1.6 into 10 power minus 8 ohm meter. So that is the resistivity is given. Resistivity is given. Now we can find out area of the cross section. Area of the cross section is 20 into 10 power minus 4. 20 into 10 power minus 4 centimeter square. Centimeter square. And length we have to find out. We have to find out length. We have to find out the length. Okay. So now resistance is given. Resistance is how much? 10 ohm. Resistance is how much? 10 ohm. So this is the given data. This is the given data. So here, whenever they given the data, we must identify. See whether all units are there in one system or not. You have to check whether there all the units are there in one system or not. We have to check. So after checking only we can do the problem. So without checking, simply if you are taking that one, so we will do mistakes. We will do mistakes. So try to identify whether units are there, all units are there in one system or not. All units are there in one system or not. We have to check. All units are there in one system or not. You have to check. So I am checking here. You can see. So row given. Row is row is no problem. So row already they given. So ohm meter. So see. And one more thing. So instead of resistivity, sometimes they will give just ohm meter. Sometimes they will give ohm meter. We have to identify whether it is resistivity or resistance. Whether it is resistivity or resistance, we have to identify. We have to identify. So here they given resistivity, and here centimeter square is given. Centimeter square is given. So remaining all are SI unit. So we need to convert. If they given in centimeter square, we have to convert. So conversion is so you can see here 1 meter equal to 100 centimeter, 1 meter equal to 100 centimeter, 1 centimeter equal to 10 mm. So but we need only centimeter. So try to do this. 1 centimeter equal to 10 power minus 2 meter. Okay, 1 centimeter square if you are taking, so 10 power minus 2 meter whole square, that is 10 power minus 4, 10 power minus 4 meters, meter power 4, okay. So now I am considering meter power 4. So sorry, meter square only, right? 4 will come for this only. So meter square, right? So 1 centimeter square equal to 10 power 4, 10 power minus 4, 10 power minus 4 so meter square. Here once again 1 meter equal to how much? 1 meter equal to 100 centimeter, 1 centimeter equal to 10 mm. So 1 centimeter 10 power minus 2 meter. So if you do it, now you can take what is the formula we can use, which formula we have to use, The formula is R equal to, so we can consider the formula R equal to rho into L by A. So this is the formula we have to use. So formula you have to use. Substitute the values. If you are substituting the values, R equal to 10. So rho equal to 1.6. 1.6 into 10 power minus 8. And L we have to find out by area of the cross section. 20 into 10 power minus 4 into 10 power minus 4. So into 10 power minus 4. So 10 power minus 4 into 10 power minus 4. How much you'll get? So check once. How much you'll get? So check once, everyone. How much you'll get? So now you can see if you cross multiply, okay. So L equal to 10 into 10 power 20 into 10 power minus 8 by 1.6 into 10 power minus 8. If you solve this one anyway, here we can cancel one thing. So now we are considering here. So this will get cancelled. This one will get cancelled. Okay. So now I am considering. See. Now I am considering. So now I am considering here. So here, so 1.6 into 10 power minus 8. 1.6 into 10 power minus 2. So this will get cancelled. Both will get cancelled here. Then after solve, after cancelling these 2 points, you'll get 200 by 1.6. Still you can do 10 by 10. Then if you can get so 2000 by okay, so by 16. So how much you'll get? So 125. 125 is the answer. So 125 is the answer. 125. So meter, 125 meter. So that is the answer. So you can check once. So this is the answer. So every time whenever they give, so you must take. So a copper wire of resistivity 1.6 into 10 power minus 8 ohm meter. So has a cross sectional area of 20 to 10 power minus 4 centimeter square. Calculate the length of this wire required to make 10 ohm coil. So first you have to identify whenever they given the question. So whenever they give the question, you must identify data. You must identify the data. So you have to recognize the data. So this is the resistivity. Ohm meter, when it gives ohm meter, if they give ohm meter, you must identify that is the resistivity. You have to identify that is resistivity. So here area they give in centimeter square. See, after writing the given data, you have to check whether all units, whether all the quantities are there in one system or not. All the quantities are there in one system or not. So check once here. So resistivity is given, area of the cross section is given. So here length we have to find out. So R equal to 10 ohm given. Now we can see here. So this is the formula. So you can check the formula. You can check this formula. Okay, so you can check this formula. Understood? So I hope it is clear to you. Right? So now use this formula. R equal to rho into L by A. R equal to rho into L by A. R equal to rho into L by A. So R is given how much? 10 is given. So resistivity is given 1.6 into 10 power minus 8. So length by area of the cross section. So I converted here. You can see 1 meter equal to here. So here you can observe 1 meter equal to 100 centimeter. 1 centimeter equal to 10 mm. 1 centimeter equal to 10 power minus 2 meter. So centimeter square we want 10 power minus 4 meter square. So if you substitute here, you will get 10 power minus 4. So 20 into 10 power minus 8. Okay. So A power n into A power n. So danger tackle. What is your name? Hi. So here a power m into a power n equal to a power m plus n according to the math. So I did. So this rule we can take 10 power minus 4 plus into 10 power minus 4 if the bases are common. So we can add the powers. If the bases are equal, then we can add the power. So according to that formula, we can take 10 power minus 4 into 10 power minus 4. We will get 10 power minus 8. So 10 power 8 minus 8, 10 power minus 8 will get cancelled. Then you will get the length is 125 meter. So is it audible? So remaining students, if it is audible, click on like button. So is it audible or not? Click on like button. If it is audible, okay. So I'll go to the next one. If it is not, let me know. I'll check once. Is it audible? Everyone, is it audible? Okay. What is your question? Tell me. Next question. We are going to the next question. So next question. So if you have any physics question, let me know. I will explain. Okay. So I'm taking this one. So now I am consider here. Go to the next one. A aluminum wire has radius. Aluminum wire. थोड़ा हिंदी आता, so sorry brother, so excuse me. Aluminum wire has radius. Aluminum wire has radius. Aluminum wire has radius 0.25 mm, 25 mm, and length 75 meter. 75 meter. If the resistance of the wire, if the resistance of the wire is 10 ohm, resistance of the wire is 10 ohm, calculate the resistivity, calculate the resistivity of aluminum. So this is the question. So you can check once. Now. We can check once. Here every time I will tell one thing. I will tell one thing. So listen carefully. First write the given data. Every time you are doing, first you must write the given data. Given data is very, very important. So given data is very, very important. First you have to note down the given data. Underline. Take one pencil and underline whether they given in meter or not. So radius. I am telling this is radius. 0.25 mm. Then 75 meter length L is 75, radius 0.25, radius how much? 0.25. Of the resistance of the wire is R value is 10 ohm. Calculate the resistivity. We must calculate the resistivity. What is resistivity? Come on, everybody focus on it. Come on, focus on the question. Every time they will give the question, you must underline, you must every time they give the question. First you have to underline whether the given data, what type of data is given. So what exactly the data you must underline first. You have to underline. Here I am taking. So here what is this one? Here is given radius, here is given length and resistivity. They are asking to find out. Crazy, hi, Marvel. Hi. So they are asking to find out resistivity. First write the given data. Data is given how much? Radius is given 0.25 mm. 0.25 mm. Length is given 75 meter. R equal to how much? 10 ohm. R equal to 10 ohm. We need to find out resistivity. Resistivity. So now you have to tell, now you have to say, now you have to say, now you have to say, now you have to say one thing, now you have to say one thing, now you have to say one thing. So whether all the units are there in one system or not, whether all units are there in one system or not, we have to check. Here you can see radius is given, radius is given. Already I said the conversion. So you must follow these conversions. Again I am writing on the board. So check once. 1 meter equal to how many? So how many centimeter? 100 centimeter. 1 centimeter equal to how much? 10 mm. 10 mm. So 1 meter equal to 100. 100 into 10. Then you will get 1000 mm. 1000 mm. 1 meter equal to 1000 mm. 1 mm equal to 10 power minus 3 meter. 10 power minus 3 meter. 1 mm equal to 10 power minus 3 meter. So 1 meter equal to 1 meter equal to 1 meter equal to, so 1 mm equal to 10 power minus 3 meter. So radius 0.2 10 power minus 3 meter. 0.25 into 10 power minus 3 meter. What is the formula we have to use? So here we have to use the formula R equal to rho into L by A. L by A, this is the formula. Very, very important. Make sure that you are learning this point. So you must understand, you should keep in mind. This question is very, very important. So, hi, Satyam. So here you have to say, so radius is given, but here we know area of the cross section, but we, so in the formula there is no radius. How to solve it? Oh my god, that's a big problem. Here's a big concern here. They didn't give area of the cross section, they only given radius. How to find out? So we have an idea. So what is that? So the electrons current will pass through the conductor. So this area of the cross section, that is nothing but circle. So that is nothing but pi r square. Pi r square. Now you are taking pi is 3.22/7. You can take or pi value can take 22 by 7 or 3.14. 3.14, any value you can consider, any value you can consider, substitute the values. So pi r square, r value is given this one. So we can also write r value 25 into 10 power minus 5. So this we can also write 25 into so hi Vaishali, hi. So here I am taking here. So 25 into 10 power minus 5. 25 into 10 power minus 5 meter. So because here two zeros are there, 10 power minus 2 values are there, right? Here two zeros are there. So these two values we can add here. 25 into 10 power minus 5 meter. 25 into 10 power minus 5 meter. 25 into 10 power minus 5 meter. So this is very, very important. This is very, very important. Now you are considering, substitute the values. 10 I am considering. Resistivity is how much? Resistivity how much? We need to find out resistivity only. Length how much? 75. Area of the cross section. 3.14 into pi into r square. R square is nothing but 25 into 10 power minus 5 whole square. 25 into 10 power minus 5 whole square. So now you can solve this one. Very, very important. Calculation. So rho equal to 10 into 3.14 into 25 into 10 power minus 5 whole square by 75. If you solve this one, they're asking about resistivity. They're asking about resistivity. They're asking about resistivity. So calculation, try to use your own method. Don't use calculators. Don't use calculators. If you use calculator, in exam time, so you will not get 100% accurate answer. You do mistakes. So that is the reason. Try to use your own method to calculate the own calculate. Try to utilize. So 25 into 25, 625, 75. So 5 you can cancel, 25 you can cancel with the table of 25 you can cancel. And here 31.4. So here 10 power 10. So like that we can use. Okay, so use your own calculation. Try to use your own calculation. So do not use calculator while solving the problem. While solving the problem, try to use your own method to calculate. But this conversion is very important. I'm saying once again, this conversion. So 1 meter equal to 100 centimeter, 1 centimeter equal to 10 mm. So 1 meter equal to 100 centimeter, 1 centimeter equal to 10 mm, 1 meter equal to, so 1 mm equal to 10 power minus 3. So here you can see, so here a volume in a whereas radius is given. Okay, so when the given radius 0.25, when the given 0.25, you must convert. So here meter, here SI unit, here also SI unit, but only. Okay, so after converting, right? So after converting only this one, so you have to convert mm into meter. Always you have to keep in mind mm must be converted into meters. Clear? So that's enough. So you'll get the answer 2.61 into 10 power minus 8 ohm meter. Ohm meter. Correct one. Now, shall we go to the next one? I will, no, one problem is very, very important. So be attention, show attention. So come on, everyone. So next question is very, very important. So observe and try to answer it. So next question. So this is a question. Everybody try to solve it. Okay, so compulsory understand the question. So underline what they given. So check once. So I'll start. So I'll give 5 minutes time. Those who are really working, you can try it once. So I'll give time. Okay, now 6:40, 6:45 will explain. 6:45. Explanation at the rate of 6:45 p.m. So 5 minutes time I'm giving. Try to solve it. So 5 minutes time I'm giving. Try to solve it. Okay, come on, everybody. Come on. Easy one, easy one. This is very easy. Very easy. So, the point is, we need to understand, as I said, the point you must understand. You must understand. Underline the point. Underline the questions. What exactly they given? What exactly they given? You have to check once here. So, underline each and every time a current. So, current is given. How much is given? So, 3 point. So current how much? What is the current? Current, come on. Current is 500 milliampere, that is I. Flows in a series circuit so compromising containing an electrical lamp. So electrical lamp R resistance. So and the conductor RL, RC you are taking RC. So when connected to 6 volts, potential difference is given. Potential difference is given. Come on, everybody, come on, do it. So check once here. If you have any doubts, you can ask me. First, you have to underline what exactly given. We have to identify compulsory. There is no other option to do the problem. You must identify the problem. What exactly given? You must identify. Without identifying, we can't able to do it. Without identifying, we can't able to do it. We must identify the data given in the question. Data given in the question. Now you can check. Now you can check. Come on. You have to check the question. Now you find the resistance of electrical lamp. Find the resistance of electrical lamp. Find the resistance of electrical lamp. You must find out the resistance of electrical lamp. First to write the given data. So I given data given data equal to my 500 milliampere. 500 milliampere and containing an electric lamp. So we have to find out RL. But RC is given. RC is how much? 10 ohm. RC is how much? 10 ohm. And potential difference we know. Potential difference is 6 volts. So by seeing the data given in the problem, you have to identify the formula. What formula we have to use? Which formula we have to use? Compulsory you have to check. Compulsory you have to check. Compulsory you have to select. Compulsory you should think. Compulsory you should get it by seeing the data. By seeing the data. So now you are using the formula V equal to IR. V equal to IR. This is the formula. So from that R equal to RL plus RC. RL plus RC. RL plus RC. So this is the formula. Now you can consider. Now you can consider. Now you can consider. Now you can consider. So V equal to. So V equal to. V equal to I. So normally substitute the direct values. You have to substitute the values. How much V is given? V is how much? 6. V is how much? 6. I is how much? Here. Very important point. Milliampere is given. Milliampere is given. Milliampere is given. 1 milliampere equal to 10 power minus 3 meter. 1 milliampere equal to 10 power minus 3 ampere. Very important. 1 milliampere equal to 10 power minus 3 ampere. 1 microampere equal to 10 power minus 6 ampere. So keeping this one in mind. Compulsory. This one you have to remember. There is no other option in exam. They won't give. So here this is the question. If they give like this, what you will do? How you will do? How you will get it without remembering, without identifying, without okay now. So keep in mind. So this point you should keep in mind. If you are not keeping that point in mind, so you can't able to solve the problem. You have to think in exam point. In exam, so that is not mega. Sir, M is there, mega, I'll write. No, that is milli. Milli is nothing but 10 power minus 3 meter. 10 power minus, so if it is ampere, 10 power minus 3 ampere. Milliampere means 10 power minus 3 ampere. Milliampere means 10 power minus 3 ampere. Milliampere means 10 power minus 3. 10 power minus 3. So keep that one in mind. So milliampere equal to, what is milliampere? 1 milliampere equal to 10 power minus 3 ampere. 1 microampere equal to 10 power minus 6 ampere. Keep that in mind. Very important. Very important. right? So now you can see 6 equal to, so I equal to 500 into 10 power minus 3, and R equal to RL we don't know, RC equal to 10, RC equal to 10, RC equal to 10. Now you see, so now you can consider, so RL plus 10 equal to 600 by 500 into 10 power minus 3. If it is comes up, so you can solve here. So RL plus 10 equal to 6 into, if it is goes up, 1000 will come by 500. So 0 get cancelled, 512. Then RL plus 10 equal to 12. RL equal to 12 minus 10. That is nothing but RL equal to 2 ohm. That is the answer. So like that way, so this is the way to solve this problem. So try to solve it. If you have any doubts, let me know. Okay na? So that is the way to solve the problem. Anybody? So is it clear? So I'm going to the next one. I'm going to the next problem. So we'll do next problem. So see, very simple problem I'll give. Very basic problem I'll give. Try to solve it. Can you try to solve this question? Anybody? So try to solve this one. I hope it is clear. Just check it once. Explanation will be, try to solve easy question only. Try to solve. So compulsory you should identify. First answer what I said, you have to identify. So I'll give clue. So I'll identify. Try to solve this problem. Okay, so I'm giving. So find the resistance of a conductor. So here, find the resistance of a conductor if the electric current flowing through it is. So current is given, I value given. I value is given. When it is potential difference. So potential difference is given V. So which formula we have to use? Which formula we have to use? What is the answer? Which formula we have to use? What is the answer? Can anybody say? Can anyone say? Very simple only, very easy only. So try to do it. Very simple problem, very easy problem. So we can use the formula V equal to IR. V equal to IR. Okay. So I value is given how much? 0.35 ampere. And potential difference is given 1.4 volts. So they are asking to find out what is the potential difference across it. Find the resistance. Find the resistance of the conductor. So they are asking to find out resistance. Resistance to find out. We have to find out resistance. So simple only, no, very easy only, right? Sir, very easy. So why are saying to us? So we can do in easy manner. Yeah, of course. So people can do, but still we have to okay, just to try, just to go through it sometimes. So how they will give, how they will ask the questions. So at least if you can, we can do it. 1.4 by 0.35 into 100 by 100. Then you'll get, so 140 by 35. How much? How much is the answer? 4. Shall we go to the next one? Next problem. So same problem, I'll give one more problem. One more problem, same manner. And I will give one more question. So this can be expected. Very, very important question. A 6 ohm resistance wire. A 6 ohm resistance wire. This 6 ohm wire is very doubled on itself. Doubled on itself. Calculate the new resistance of the wire. Calculate the new resistance of the wire. How to do it? So very important question. How to do it this problem? Can anybody say? How to do it this problem? So here you can see. So here you can observe. Okay, first you have to check. See, a 6 ohm resistance. So R is given. Doubled on itself. Doubled on itself. Calculate the new resistance of the wire. Doubled on itself. So in this case, so I will explain here. You see, I am taking the straight wire. So this is the straight wire. So this is the straight wire. So doubled on itself, it is folded. So if you are taking the straight wire, doubled on itself, so it is folded on it. 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 So if you are taking this wire, okay, so this is a complete wire. This is length of the wire. Length of the wire. Doubled on itself. Doubled on itself means, so like this. It is folded like this. It is folded like this. What happens in this case? Length is decreased. Length is decreased. That is, length is decreased. How much it is? Length is decreased. Decreased. So how much it is decreased? So L by 2. So area of the cross section is increased. So I'm taking once again, here you can see this is the length of the wire, this is the length of the wire, this is the length of the wire. So it is doubled on itself, doubled on itself. So doubled on itself means so it is folded like this. Okay. So length is L by 2, area of the cross section is 2A. So A, 2A, A, 2A. So the like that you have to take. So I'm considering now. Initially is L by 2, so here is the cross section 2A. L by 2 and 2A, L by 2 and 2A, right? So that's enough, that's enough. Now you are going through that. So now you can check once. So substitute the values. R equal to R, myopia, near distance we can see, far distance we can see, myopia, for that correction we are using, bro, what bro? For that correction we are using concave lens, thicker thin. Huh? Sir, in which wire will be resistance will be high? How resistance will be high? Resistance will be less only here. So when you are folding here, when you are folding like this, so like this, normally this is the wire, okay, so this is the length of the wire. When it is folded on it, high, Ishiti aga, what high, Shivani, just check once. So I am taking here, this is the wire you can consider. So it is folded on it. If it is folded on it, area of the cross section increases. So then, so resistance will be less. So flow of current will be more, because initially this is one area of the cross section, later it will be added like this. So more, then area of the cross section increases, then resistance will be less. Okay, so that's enough. Hi, Chahar, welcome to the class. So now I am taking R1 equal to rho into L1 by A1. So that value, R1 value already given. R1 value is 6 ohm. Now R2 equal to R2 formula is rho into L2 by A2. So rho into L2 equal to how much? L2 equal to L by 2. A2 equal to how much? A2 equal to 2A. A2 equal to 2A. So R2 equal to, sir, no, I am not asking relating to this question. In which wire will the resistance will be high? Thin wire only. Velocity will be less. Thin wire, small wire. Best example, so water pipe is there. So if you are so pressing at the end, so if you are reducing the volume, how it will be? So more resistance will be. If you are leaving more, so more velocity will go, so more electrons will flow, right? More electrons will flow. So that's why thin wire has more resistance than thick wire. Thick wire should allow the electrons. Okay, so now we are going to the next ones here. R2 equal to rho into L2 equal to how much? L by 2. So substituted, right? Directly L, right? So now you can see rho equal to L by 4A. From this 1 by 4 equal to rho into L by A. So rho equal to, so rho L by A. That is nothing but R. Rho L by that is nothing but R. Rho L by that is nothing but R. So R2 equal to 1 by 4 into R1. R1 value how much? R1 value we got 6. R1 value already given in the question. Already they given in the question. Velocity displacement by time taken. So 6 by 4 that is nothing but 3 by 2. So R2 equal to 1.5 ohm. R2 equal to 1.5 ohm. Angulation equal to what happened? Okay. Change in velocity by time taken. Can I know your name? Anyway, you are asking questions, no? So by calling name, I will tell. What is your name? Can I know your good name? New Cartesian sign convention. New Cartesian sign convention. All the distance measure from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. I will tell 100%. I will tell with one condition. If you say your name, I will tell. So V equal to U plus AT, S equal to U2 plus half AT square, V square minus U square equal to 2AS. Any doubt? So now 3 resistance question. 3 resistance. A 3. So question 3. Very very important question this one. 3 2 ohm resistors. 2 ohm resistors A, B and C are connected in such a way that the total resistance of the combination me 10th class. Definitely I'll prove, don't worry about it. Of the combination, this is total resistance of the combination is 3 ohm. Show the arrangement. But the way of you asking question, I liked it here. So I like you, boss. So really nice. The way you are taking me into the explanation part, are asking me to answer the questions. Really amazing. So really, I am very hats up to your intelligent. Maybe even you're not saying your name also. I am very we can say what we can say. I'm surprised. I'm surprised for your questions. Yeah, of course, boss. Joshua, then thank you, sir. No, the one person. Hi, sir. I am back when I'll be. Hey, Daniel, don't worry, Daniel. See, I am there here. Okay, so you are there here. So definitely. So what will happen? Nothing will happen, right? So Sukesh Verma, hi. How are you? Okay. This question is very important. This question is very important. Sir, when is so whenever you want that time only we will do it. So very important. So everyone, now okay, class is going on now. So here so don't love you mentioned. So really I like you, boss. Really I'm very happy for you because not the way you are asking questions and taking it to the final point. So really yes, Jesh Vardhani, very nice. That is correct. Two in parallel, one in series. That is good, very good. I'm clapping for you. So nice. So if you know the answer, this interaction class, so you can try to answer it. So they given 3 ohm. Show like ABC are connected. Okay, so 2 ohm resistor, 3 ohm resistors connected in such a way that the resistance of combination must get 3. Show the arrangement of 3 resistors. Justify your answer. Yeah, correct. That is correct. So that is correct. Very good. So very nice. So someone is saying, what is your name? Uh, Josh Vadwani. Josh Vadwani. Very nice. So nice. Great. So now you can see. Now you can see here. Answer. So 3 ohm resistor. So I'm taking 1, 2, 3. So 2 ohm, 2 ohm, and 2 ohm. So 3 resistors are given. You can connect however you wish. You can connect however you wish. In your own way, you can connect. In your own way, you have to connect. You can connect anyway. You can connect in any way. So I want a 3 ohm resistance. I want a 3 ohm resistor. Final answer 3 ohm resistance. How can you connect? How can you connect? So Josh, so very nice. So yes. So here you can see I'm taking 2 in parallel, 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 2 in parallel. Sir, sir, sir. One person said directly the answer. Okay, so 2 in parallel, 1 in series. But if I don't know the answer, how to do it, sir? If I don't know the answer, how to do it, sir? How to take, sir? Yes. I will tell them small logic. I will tell them small logic. I'll tell them small logic. So we know resistors are in series, resistors are in parallel. So check once. First you check. Resistors are in series. So these 3 resistors you connect in series combination. 2 plus 2 plus 2. How much? Will you get 3? Never. Because 2 plus 2 only 4. If you add 2 resistors only, you'll get 4. If you add one more, you'll get 6. So that is not equal to 3. Definitely. Second option. So sir, I have another option, sir. We can try that option. Yes, you can try. So 1 by 2, 1 by 2, 1 by 2. Will you try this option? If you try also, how much you'll get? 2. 1 plus 1 plus 1. That is nothing but 3 by 2. So, but we want R value. R value equal to 2 by 3. So, that is not equal to 3. Never equal to 3. Sir, but how to do it, sir? Try in different method. trying different method. So you can't stuck it with only one method or two method, right? You can you can try in different methods, right? You can try in different methods, right? You can try in different methods. Sir, now we are practicing, but in exam time we will miss, we will forget, we don't know how to solve it in exam hall, sir. Yes, in exam hall, so you follow only two methods first. One is resistors are in series. Next one, resistors are in parallel. First one is resistors are in series. Next one, resistors are in parallel. In these two methods, 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 the problem is not coming. The problem is not coming. Go for different methods. Go for different methods, boss. Nothing happens, right? Nothing will happen. So we don't have any concern also, right? So that is the reason, try experiments while you are practicing. Do experiment, lot of experiment you do, nothing will happen, no. So once you do experiment, you win. If you win, you will be example. If you lose, you will get some knowledge, you will get some knowledge. Okay, so Thomas Alva Edison, so he failed 1,000 times. So before finding the electrical bulb, Thomas Alva Edison, so he failed 10 times to identify the electrical bulb. So but still he didn't give up, right? He didn't give up, right? He didn't give up. He didn't give up. So finally, that time he said, so I found the 1,000 ways to 1,000 ways. In that 1,000 ways, I am not getting the result. I am not getting the result. So I have to go for another method. I have to go for another method. I found 1,000 ways are not working. So I have to go for another method. Okay, so think about it. Think about it. So if these two methods are not working, if these two methods, with the two methods, resistors are in series, resistors are in parallel. If these two methods are not working, so you are not getting the answer, no need to worry about it. So do experiment, lot of experiments you do. See, so don't depend on other boss. Okay, so problems, so subject, content, try to do your own. Try to do your own. If you are getting, as I said, if you win, so that is an example. If you lose, no problem, nothing will happen. No. So what is the problem? If you fail also, nothing will happen, right? So while practicing, while working, if you are not getting also, you won't lose anything. You won't lose anything. So you'll get the knowledge. You'll get to knowledge. So how to do it, in which way I have to go. So I went in this way, I went in this way, I didn't work out. So these methods are not working for me. I have to go with a different method. So you can try in that method. That's enough, no? There is no wrong in that, right? No one will question you, right? Why you're doing these methods, why you're not doing. No. It's not like that. So we have to we have to succeed. We have to succeed, right? We have to prepare, we have to learn the knowledge. That is what we want. That is what we want. Yes or no? So for that, what you have to do, you try your own method. You have to try your own methods in life. So your own knowledge, your own ability, your own knowledge, your own ability, your own capacity will lead you success. Okay, so no, someone won't come and give you success. You want that success? You want this one? You want this? You want to become topper? You want to become great? Okay, take it. No one will give you, boss. How they will give? Who are free to give your success? You have to achieve your goals. You have to achieve your dreams. You have to work for it. You have to work it for it. Lot of work. So simply, if you try one time, so I'm not getting. If you try two times, I'm not getting. That is not acceptable. Society will not accept you if you try one time. You must be very strong, very strong. You must be very strong mentally and physically. Then only you can succeed in life. Okay, so you have to work for your goal. 1,000 times, 2,000 times if you fail also. Try one more time. Stand and try one more time. Definitely you will win. Definitely you will win. Okay, so the point here, if one method is not working, go for another method. Try in different ways. Try in different ways. Okay, definitely. So among those, one method will give you result. Only one method. So maybe all those methods may not give success, may not give you result, but one method definitely guarantee will give us. That method you have to identify. For identifying that method only, so our talent lies. Okay, na? For identifying that method, which method will work for me, which method I need to work out, which method is which method will give result to me, will give success to me. To identify that method only, so lifetime will get over. Okay, so go and do your work, hard work. Try, no problem, nothing will happen. So only one thing from my end, do hard work, do lot of hard work. Okay, so failure should feel guilty by seeing you, so because of me is not getting the success, like that failure should feel guilty. See how hard this statement it is. Okay, the statement itself, so it should feel guilty. Failure should feel guilty. Why? So because of me, this guy, this person not getting the success, like that. Means that much hard work you have to do. Lot of hard work. Lot of hard work. With the proper goal and proper aim and proper direction that is required. Okay, so that's enough. That is about class. So still we can do problems. Still a few more problems. So there are there are many problems are there. Many problems are there in electricity. So we are doing one by one. I completed the chapter, electricity chapter today. So we are doing problems. Still we'll do problems. Join at 9 p.m. today. Join at 9 p.m. today. So we'll work out. We'll do problem. So join at 9 p.m. today, evening time, 9 o'clock. So again, live class is there. Join at 9 p.m. So we'll get we'll solve so few problems, few more problems, few more models. Not problem, few models, different models. Okay, so one model, another model, like that. So how many models we can able to cover, we will do it. Okay, next one we have to do circuit problems also. Circuit problems also we'll try it. So until then, this is your Siva sir from Student the Brand. If you like this content, if you like this video, so if you like the channel, please do like, share and subscribe to Student the Brand. So if you like this one, you can share to your friends. So ask your friends to join to the class. So let them learn. Okay, so until then, bye, see you, thank you.